Hello student, I hope that you are good, well and fine. In today's session, we will be seeing about linear differential equation. So linear differential equation, what are linear differential equation? If our differential equation given in this form, in this specific form, which is y prime or dy by dx plus py is equals to some q, where p and q are either constant or some function of x only. Okay, clear? Is known as linear differential equation, first order linear differential equation. First order, why? Because as you can see, the order of this differential equation is 1. Yes, so that's why first order linear differential equation. Now some of the examples are dy by dx plus y is equals to sine x. As you can see, p is 1, q is sine x. So p and q can be constant also, and p and q can be function, but function must be in x only. So dy by dx is equals to 1 by x, y is equals to ex. dy by dx plus y by x log x is equals to 1 by x. Okay, another first order linear differential equation form will be what? Dx by dy plus p1 x is equals to q1. Okay, now p1 and q1 must be constant or must be function, but in terms of y only. Okay, in terms of y only. Clear? Okay. For example, dx by dy plus x is equals to cos y. Dx by dy plus minus 2x by y is equals to y square e minus y. Okay. Now, in order to solve first order linear differential equation of the type dy by dx plus py is equals to 0, sorry, q, what you have to do? You have to multiply both sides by what? By gx, by some function of x which is gx. So gx divided by gx multiply with dy by dx plus p multiply gxy is equals to q multiply gx. Clear? Okay. Now we have multiplied this, we have choose this gx in such a way that right hand side, this right hand side becomes a derivative of this y dot gx. This means this right hand side must be derivative of this. We have choose such g. Okay, so this will be what you can also rewrite it as gx dy by dx plus p product with gxy is equals to derivative of y dot gx. Okay, now what you have to do? You have to derivate it. You will get what? Gx dy by dx plus y g prime x. Okay, now what you have to do? Now this p product with gx is equals to g prime x. What? That it says what it says. If you try to see, okay, if you try to see that what happened is that this term is equal to this term. Yes, this term going to be same as this term. By comparing, this will give you p product with gx is equals to g prime x. This means p will be ratio of g prime and g. This means integrate both sides, you will have p dx is equals to integration of g prime divided by gx dx. Now take gx as t, substitute, you will get log of this integration will be log of gx. That's it. And this will be what? Integration of p dx. This means rearranging terms, applying log property, you will have gx is equals to e power integration of p dx. So gx, the function you are required, which will be e power integration p dx. Okay, so this thing will be, we will be calling it as integrating factor. This thing we will be calling it as integrating factor. Clear? Okay. Now, so after substitution, what you will have? E integration p dx dy by dx plus p e power integration p dx y is equals to q product with e power integration p dx. So this left hand side can be rewritten as derivative of this thing, this term y e power integration p dx is equals to, and right hand side can be shown as q multiply with e power p dx. Now this, after integrating both sides, you will have y product with e power integration p dx is equals to integration q multiply e power p dx dx. So this means y, the final answer or the general answer for the first order linear differential equation will be this. Okay, either you have to memorize this or you can memorize the steps. Okay, now steps involved to solve first order linear differential equation. First step, okay, first step, write the given differential equation in this form: dy by dx plus py is equals to q. Now find the integrating factor by using e power p dx. P you can easily get from this form. Okay, p will be the coefficient of y. So now, so your integrating factor will be this. Now your final answer will be y multiply with integrating factor is equals to integration of q multiply with integrating factor dx plus some constant. This will be your general answer of the given differential equation, the first order linear differential equation. Okay, but what about this case? Dx by dy plus p1x is equals to q1. The same, the little difference will be what? Here you have the integrating factor as e power p dx. Here you will be having e power integration p1 dy in terms of y. Okay, p1 dy. Okay, okay, so this means the final answer will be x multiply with integrating factor, y multiply, you can see the pattern. Okay, integration q1 multiply integrating factor, as you can see pattern following, dy plus c. Clear? Okay, now some examples. Solve this. Dy by dx minus y is equals to cos x. As you can see, p is minus 1 and q is cos x. So integrating factor will be e p integration p dx. This means e power minus 1 dx. This means e power minus x multiply with integrating factor both side. Okay, you will get what? You will get this. This means, or generally the final answer we have, as we have already shown you here in steps, that y multiply with integrating factor is equals to integration q multiply with integrating factor dx plus some constant. We every time we are going to use that, so it will be y integrating factor integration integrating factor q dx plus some constant. So this integrate this using what? By parts. Okay, we are using by parts. In by parts, what we are using? We are using cos x or this trigonometric function as first function and this as second function. Okay, now so after using by parts you will get this. Clear? I hope that you can easily find out using by parts. So you will have the integration capital I for this as sin x minus cos x multiply with e power minus x divided by 2. Now substitute this integration, you will get your final answer in this form. Okay, okay, now example, next example. So solve this. In order to, first of all, try to make it in standard form, which is dy by dx plus py is equals to q. Okay, so divide by x. Okay, both side you will get what? Dy by dx is equal plus 2 multiply y by x is equals to x. This means p will be 2 by x, q will be just x. So integrating factor will be integration of x 2 by x dx. So it will be e power log x square. This means just x square using log property. Now using the final form, y multiply with integrating factor is equals to integration integrating factor multiply with q dx plus some constant. So integration of x q dx plus some constant, this means x power 4 by 4. Okay, now multiply or divide both side by x square, you will get the final general solution as this: y is equals to x power 2 divided by 4 plus c x power minus 2. Okay, next example. First of all, try to make the general form. You will have dx by dy minus x by y is equals to 2y. This means p1 will be minus 1 by y, q1 will be 2y, integrating factor will be e power integration p1 dy, as you can see. So it will be, after simplification, you will have 1 by y. Clear? So this means what? So the final form is x multiply with integrating factor is equals to q1 multiply with integrating factor dy plus some constant. So you will have what? X by y is equals to 2 dy plus c. This means x by y is equals to 2y plus c. Cross multiply with y, you will have x is equals to 2y square plus cy. Okay, this will be your general solution of the given differential equation. Now next example. Find the particular solution. Here we have to find the particular solution. So first we have to find the general solution and then particular solution according to the condition. Integrating factor, first of all, p will be cot x. Okay, q will be 2x plus x square cot x. Okay, now integrating factor will be e power integration cot x dx. This means e log sin x. This means just sin x. Final form will be y multiply with integrating factor is equals to integration q multiply with integrating factor, as you can see, dx plus some constant. Now this can be separated as 2x sin x integration and x square cos x integration. You know this integration. How you are going to do? Quite simple, using the by parts. Okay, using by parts, first function is this and second function is this 2x thing. Okay, you will get this. We are not touching right now this term. Okay, so why, as you can see that this integration and using the by parts, you will get some extra term, the same term as this but different in sign, so this will be cancelled out. You will have y sin x is equals to x square sin x plus c. Now in order to get your particular solution, substitute y is equals to 0 and x is equals to pi by 2. This means 0 is equals to pi square by 4 plus c. This means c will be minus pi square by 4. So your value for c will be minus pi square by 4. Okay, so your particular solution will be of this form, which is y is equals to x square minus pi square divided by 4 sin x. Clear? Okay, next problem. Okay, problem this or example. You have to find the equation of a curve passing through this point 0, 1. If the slope of the tangent to the curve is this at any point is equal to the slope is equal to what? Sum of x coordinate and the product of x coordinate and y coordinate. This means x plus xy. As you can see, dy by dx will be x plus xy. This means dy by dx minus xy is equals to x. This means p will be minus x, q will be x. Use the integrating factor. Integrating factor will be e power minus x square by 2. After getting integrating factor, apply the final form, which is y multiply with integrating factor integration q multiply with integrating factor dx plus some constant. Solve it. Okay, after substitution you will get what you have to substitute: minus x square by 2 is equals to t. This will gives you x, dx can be replaced by just minus dt. This means your integration will be what? Minus integration e power t dt. This means minus et. This means substituting back your t value, you will get your minus e power minus x square by 2. You will now this is your what? The integration for the required thing. Substitute it. You will get your final answer as y is equals to minus 1 plus c e power x square by 2. This will be your general form. What about the particular form? In order to get your particular form, you have to substitute the conditions, which is x 0 then y is 1. So x0, put x0, this will give you c is equals to 2. So c is 2. So your final or the particular solution will be y is equals to -1 plus 2 e power x square by 2. Clear? I hope it is clear. Now let us move to NCERT exercise 9.5. Okay, based on this concept. Okay, we'll try to solve. Okay, so we have to solve, or we have to find the general solution. So here as you can see, p is 2, q is sin x. So p is 2, q is sin x. Integrating factor will be e power 2x. And this form, y multiply with integrating factor, integration q multiply with integrating factor dx plus c. Now here we will be using the by parts thing. So in order to get this, we will be using by part thing. So first function as sin x and second function as this e power 2x. So after using the by part, you will have this. Now again in this term we are going to use by parts. So after getting again by parts, you will have this as your form, which will gives you I is equals to e power 2x divided by 4 2 sin x minus cos x minus 1 by 4 I. This means rearrange I terms. Okay, you will get I is equals to e2x divided by 5 multiply 2 sin x minus cos x as your integration required integrating. Okay, substitute this integration, you will get your final or required general form of the given differential equation as this. Okay, clear? Now next second, p will be 3, q will be e power minus 2x. So integrating factor will be e power 3x. Now using this form, you will have y multiply e 3x is equals to e multiply minus 2x multiply 3x plus c. So this is just integration of ex, which is just ex. So your general solution will be y is equals to e power minus 2x plus c e power minus 3. Okay, now third problem. P will be 1 by x, q will be x square. P will be 1 by x, q will be x square. This means integrating factor will be just x. Okay, using this form, y integrating factor is equals to integration q integrating factor dx plus some constant. This means y multiply x, this is multiplication product, not a function, this is product. Okay, x y, if you comfort with this. Okay, xy is equals to integration of x cube dx plus c. This means xy is equals to x power 4 divided by 4 plus c. So this will be your required general solution. Now next problem, p will be sec x, q will be tan x. P will be sec x, q will be tan x. So integrating factor will be sec x plus tan x. Clear? Sec x plus tan x. So using this, you will have y sec x plus tan x is equals to integration tan x multiply sec x plus tan x dx plus c. So after distributing, you will have sec x tan x integration and tan square x. This integration is just sec x. This integration we have to replace tan square x by some form of sec, which is sec square x minus 1. Now you know this integration is tan x and this integration is just x. You will have your general form as this. Okay, now fifth problem, p will be 1 by cos square x, which is sec square x, and q will be what? Q will be sec x and what? Q will be tan x and sec x. Sorry, q will be tan x and q will be sec square x and tan x. Okay, so as I have already told you that p will be sec square x and q will be, what we have done, we have just divided both sides by cos square x. That's why tan x and cos square x gives you what? Gives you tan x multiply with sec square x. Okay, this form. Okay, so p will be sec square x. Now integrating factor will be e power tan x. Integrating factor will be e power tan x. Now using this form, you will have y multiply e tan x is equals to integration sec square x tan x e power tan x dx plus some constant. Now take 10x as t. This means sec square dx can be replaced by just dt. You will have t e power t dt. Now use by parts. After by parts, you will have y multiply et is equals to t et minus et plus c. Now substitute back your t value. You will have y x e power 10x is equals to 10x e power 10x minus 10x e power 10x plus some constant will be your general form. Now sixth problem. So your dy by dx plus 2y by x, y is equals to x log x will be your standard form. This means p will be 2 by x, q will be x log x. So integrating factor will be x square. Integrating factor will be x square. Using this form, y integrating factor is equals to integration q integrating factor dx plus some constant. You will have x square y is equals to integration of x q log x dx plus some constant. Use by parts. After using by parts, you will have let me just skip all these in between steps, so please do the respective steps. So x square y is equals to x power 4 log x divided by 4 minus 1 by 4 multiply x power 4 divided by 4 plus some constant. Okay, rearranging some terms, okay, you will get your general solution as this: y is equals to 1 by 16 x square product with 4 log x minus 1 plus cx minus power cx power minus 2. Now seventh problem. So first of all, try to make it the general form. So general form will be dy by dx plus y divided by x log x is equals to 2x square. So p is equals to x log x, q will be 2 divided by x square. This means integrating factor will be just log x. Apply this formula. You will have y log x is equals to integration of 2 divided by x square log x dx plus some constant. So now what we are going to use? We are going to use the by part thing. So after using by parts, you will have minus 2. The integration for this will be minus 2 by x 1 plus log x. Substitute this. You will get your this as your general solution. Y log x is equals to minus 2 by x 1 plus log x plus some constant. Now next problem. The general or the standard form will be dy by dx plus 2xy divided by 1 plus x square is equals to cot x divided by 1 plus x square. This means p will be 2x by 1 plus x square and q will be this right hand side expression. Integrating factor will be 1 plus x square. Use this form. You will have, okay, y multiply with 1 plus x square is equals to integration of cot x divided by 1 plus x square product with 1 plus x square. So this means these two terms can directly cancel. Integration of cot x we know, log of modulus sin x. So your general solution will be this equation. Okay. Now ninth problem. Try to make it into standard form. Standard form will be dy by dx plus 1 by x plus cot x multiply with y is equals to 1. So this means p will be 1 by x plus cot x, q will be just 1. So integrating factor will be x sin x, as you can follow this. Okay, x sin x. Now applying your integrating factor in this form, you will have y x sin x is equals to integration of 1 multiply x sin x dx plus. Now use by parts. By parts, using by parts, you will have first function as x and second function as sine. So you will have, after applying the by parts, you will get y x sin x is equals to minus x cos x plus sin x plus c. Just rearrange your terms or divide both the side by x sin x. You will have y is equals to minus cot x plus 1 by x plus c by x sin x. Okay, I hope it is clear. Okay, let us move to the next problem. Okay, so standard form will be dx minus x is equals to y. This means p will be minus 1, q will be just what? Y. Okay, so integrating factor is e. Here this form is dx by dy. This means integrating factor will be integration of p dy. This means e power minus y. Now your general solution will be of the form x multiply with integrating factor is equals to integration q multiply with integrating factor dy plus some constant. Now you will get this as your equation. This integration we will be solving by using by parts. So after applying by parts, you will have x e power minus y is equals to minus y e power minus y minus e power minus y plus some constant. Rearrange some terms. Okay, you will have x plus y plus 1 is equals to c e power y. Okay. Okay. Now, next problem, 11th problem. What it says, 11th problem. try to form the standard form. Okay, so dx by dy plus x by y is equals to y. This means q will be 1 by y, sorry, p will be 1 by y, q will be just y. So p will be 1 by y, q will be y. Integrating factor will be e power p dy. This means just y. Now the final form with the respective form will be what? X integrating factor is equals to integration of q multiply integrating factor dy plus some constant. This means xy is equals to integration of y square dy plus c. This means x will be y square by 3 plus c divided by y will be your general solution. Now next problem. Reduce in standard form. Form will be dx by dy minus x by y is equals to 3y. This means p will be minus 1 by y, q will be 3y. So p will be minus 1 by y, q will be 3y. This means integrating factor will be e power p dy. This means 1 upon y, just 1 upon y. Use the corresponding form for dx by dy thing. You will have x multiply with integrating factor is equals to integration of q multiply with integrating factor dy plus some constant. This means x by y is equals to 3y plus c. After integration you will get this. After rearranging some terms you will get x is equals to 3y square plus 3y as your general solution. Now here you have to find the particular solution. Okay, so let's just see quickly. So reduce in standard form, it is already reduced. So you will have p as 2 tan x and q as sin x. So p as 2 tan x and q as sin x. Integrating factor will be sec square x. Now use this form to get your general form. So you will have y sec square x is equals to integration of sin x product with sec square x dx. This can be reduced to sec x tan x. So we know the integration which is just sec x. So y sec square x is equals to sec x plus c. Apply x is equals to 3 by pi by 3 and 0, y as 0. So this left hand side will be vanished, right hand side will be sec pi by 3 which is just 2. So c value will be minus 2. This means your particular solution will be y is equals to cos x minus 2 cos square x. Clear? Okay, I hope it is clear. Okay, now 14th problem. Reduce into a standard form. You will have dy by dx plus 2xy divided by 1 plus x square is equals to 1 divided by 1 plus x square whole square. This means p will be 2x divided by 1 plus x square and q will be this right hand side expression. This means integrating factor will be 1 plus x square. You can perform the corresponding steps. So you will get integrating factor as 1 plus x square. This means now using this form to get the general form, you will have y multiply with 1 plus x square is equals to integration of 1 q which is 1 divided by 1 plus x square whole square multiply with 1 plus x square. You can reduce it. You will have this, and this integration is direct tan inverse x. Now you have the general answer, general solution as y multiply with 1 plus x square is equals to tan inverse x plus some constant. Now according to the condition, if x is 1 then y will be 0. This left hand side will be vanished. This will be what? Pi by 4. Okay, if x is 1, this means tan inverse 1 will be pi by 4. So c value will be minus pi by 4. So your particular solution will be y multiply with 1 plus x square is equals to tan inverse x minus pi by 4. Now 15th problem. Okay, so in 15th problem, still you have to, according to the given condition, you have to find the particular solution. So here you can see that the p is minus 3 cot x and q is sin 2x. So p is minus 3 cot x. So integrating factor will be 1 by sin cube x. Okay, 1 by sin cube x. If you perform the corresponding steps or the steps accordingly, you will get 1 by sin cube x. Now use this form to get your general solution. General solution will be y product with 1 by sin cube x is equals to integration of sin 2x product with 1 by sin cube x dx plus c. So as you can see, this sin 2x can be reduced to 2 sin x cos x. This means sin will be cancelled and you can reduce your form as cot x and cosec x. So this will be, and you know the direct integration for this, you have 2 cosec x. Yes, so your general solution will be y is equals to minus 2 sin square x plus 3 sin cube x. This now after applying your conditions, you will have c value as 4. This means your particular solution will be y is equals to 4 sin cube x minus 2 sin square. Clear? Now 16th problem. 16th problem says that you have to find the equation of the curve passing through the origin, given that the slope of the tangent to the curve at any point is equal to the sum of the coordinate of the point. So dy by dx is already given, that sum of the coordinate, which is x plus y. So dy by dx can be rewritten as, this equation can be rewritten as dy by dx minus y is equals to x. This means p will be -1, q will be x, integrating factor will be e power minus x. Using this formula you will get the general solution as y e power minus x integration x e minus x dx plus c. Use by parts here. After applying by parts, you will have this integration as minus e power minus x multiply x plus 1. Substitute your integration value here. You will have your general solution as y multiply e power minus x is equals to minus e power minus x plus 1 plus some constant. This means x plus y plus 1 is equals to c multiply e power x. Now, okay, clear? As you can see, clear? Okay, I hope it is clear to you. So okay, now if the curve passes through the origin, this means x0 y0, this means put x0, you will have c is equals to 1. This means c value is just 1, so you will have the required curve as x plus y plus 1 is equals to e power x. Okay, as it is already given that your curve must pass through the origin. This means x0 y0, you substituted your condition, you will get your c or constant value as 1. Okay, now 17th problem. Okay, so as we do not have extra time, okay, time is also running out, so I hope that the remaining problems, only 17, 18 and 19 problems are there. Only 3 problems we have left for you, so please do as your homework. So this is it for now. Thank you. We will be back with more theory and exercise again. Thank you.